revision in uh, 2 lessons, not more than that. And then we will try to solve some of the worksheets. Here, along with this, where I will feel suitable, I will show you some of the questions and we will practice the worksheet you have received. So in waves, actually, when we talk about the waves, waves have 3 sections: general waves, sound waves, and electromagnetic waves, right? So when we talk about a wave, waves have some properties. I mean, wave is just the disturbance of the medium and propagation of that disturbance from one point to another point in the form of vibration of particles, simply speaking, right? In the form of particles vibration. But here we go. What are the properties of the waves? There are several properties and they all are asked to you one by one. That what is amplitude? Actually, amplitude is the maximum distance of the vibrating body. Here is that amplitude. For example, if you say that this is the mean position, and if I go through from this mean position to this top position, I mean above the mean position, right, above the equilibrium position, the highest distance or largest distance, are below that, this is the amplitude, right? Is it clear to you?
Right.
And then uh, the second is wavelength. Wavelength is basically the distance between two peaks. It can be your time period also, but if it is distance, then it will be called your wavelength, right? But if it is time, that will be called your time period, right? Time period in terms of time, and distance agar hoga, so that will be called your time period. Now the next is the frequency. Frequency is number of waves passing through a point in a second. So number of waves made in 1 second, a number of waves passing through a point in 1 second. So will you remember this?
Yes, sir.
Okay. Then we have the wave equation. Actually, wave equation is the sorry, wave speed, that is v is equals to f lambda. This wave speed is a wave equation also. So that was one of the point you have to remember, where f is the frequency, v is the lambda is the wavelength. And somehow we can consider that if your frequency is equals to 1 upon time period, frequency is also equals to 1 upon time period, so we can say that this speed is equals to lambda times t, right? What can be that one? It is, sorry, lambda divided by t. Yani v is equals to distance divided by time hota hai na, it is lambda divided by t. So you have to keep this point in your mind. Then there is a definition of wavefront. What a wavefront is? So wavefront is basically the portion of the wave with equal distance, equal position, and equal energy level. Let's say if I say these all lines are wavefronts, these all lines are your wavefronts, right? So wavefront can be circular, semicircular, straight. The distance between two lines or two wavefronts, that is a lambda. So this, the question is asked to you sometimes, that what is this distance, or sometimes it is asked that this distance is, so how much that distance is, it is your 2 lambda, right? So you have to keep this in your mind, that the wavefront distance between two wavefronts is always a wavelength. Okay, so wavelength is a line which joins all identical points. That is just wavefront, or a simple definition of wavefront. So is this clear to you? Yes, Ariba, are you there?
Sorry, sir, my mic wasn't opening. Could you re-explain what wavefront means?
Yeah, wavefront means the line joining all identical points of a wave. For example, if I have different waves and I join the peaks of all the waves, then I will get a wavefront, right? Here are the waves, and these are different waves actually. They are passing in this they are moving from left to right, and I'm going to join the peaks all of these waves. This is a wavefront, this is a wavefront, this is a wave, right? If you throw a stone in the pond, you will observe that you will get the circular ripples. So actually, what are those? Those are the crusts and troughs, na? Isn't it?
Yes.
So those are the wavefronts. So now you got that what a wavefront is.
Yes, sir.
Okay, so the distance between two peaks is actually called the lambda. So that's why we call the distance between two wave fronts is also equals to lambda. So here we go. Here I have mentioned all these I mean these terms here, that if I see this diagram, check that one. This the green color is the main equilibrium position. This black line is wavelength. This one is your trough. The lower peak is trough. The upper peak is crust, right? The distance between one crust and one trough is lambda by 2. The height of the wave is amplitude. Is it? So these are the points actually we have to remember. Got it?
Yes, sir.
And peak to peak distance, this orange color line, this one, that is actually from distance of one peak to the other peak. This one, this is actually what? This is your double of amplitude, twice of the amplitude, half amplitude above and half of the amplitude below. Right? Is it clear to you?
Yes, sir. Could I just look at it one more time?
Yes, yes. Why not?
Sir, you said the point to point distance is called
It's wavelength,
wavelength. Okay.
right?
Yes, sir.
So,
Um,
yeah. Any other question you want to ask?
no, sir.
Okay. So here is that wave equation, the relation between the frequency and time period and wavelength and frequency and speed. So as I told you that these are two triangles. This triangle is relating frequency is equals to 1 upon time period. Okay, frequency is equals to 1 upon time period. It means inverse of time period is equals to your frequency. Inverse of time period is equals to frequency, or if you want to take time period, that will be equals to 1 upon frequency. We use this stuff in calculation. And secondly, v is equals to f lambda is used. This is actually the equation v equals to f lambda. So if you need v, lambda and f will be multiplied. If you need lambda, v and f would be divided. If you need f, v and lambda will be divided to each other, right? So आपने
Right,
याद क्या
sir.
करना है? Simply v is equal to f lambda and f is equals to 1 upon t. Then yeah, here it is. Frequency is 1 upon t and frequency is v upon lambda also. So general definition of that is number of waves divided by time taken. Is it clear?
Yes, sir. Clear.
Small t is the total time taken and capital T is time taken by one wave. So that is the time for a single wave. Okay.
Okay.
Now here is an example. Example mean a vibrator have vibrates or it has a vibration 3000 vibrations per minute. I mean 3000 waves per minute actually. Waves per minute. Calculate the frequency. So you know frequency is equals to number of vibrations or number of waves divided by time taken. That's simple. So 3000 waves are produced in 1 minute means 60 seconds. So it is providing you the value 50 and unit of the frequency is hertz. That's it. Okay, is it clear to you? Any question?
No, sir. No question.
Okay, now go to the next type of the wave. Waves have different types, right? This slide is actually the types of waves. the types of waves. So when we talk about types of waves, there are two main types. One of them is mechanical waves, and the second one is non-mechanical waves. I would divide them in two, and then I will further go to the classification. One, mechanical. They need medium, right? They need medium. Without medium, they cannot travel. And the second one are non-mechanical. What does it mean by non-mechanical? They do not need any medium. No need of medium. No need of medium. Are you getting it? So when they do not need any medium, so we can consider these are actually the all electromagnetic waves. All electromagnetic waves are non-mechanical waves. But those waves which need a medium, we classify those with respect to the motion. One of them is transverse wave, the second one is the longitudinal wave. You have to keep these points in your mind. Longitudinal waves are those waves in which the vibration are parallel to the direction of propagation of the wave. Here are the examples. I will tell you the definitions. Check. The vibrations are moving along the direction of propagation. And sorry, transverse waves. Here are the longitudinal waves. So direction of vibration is moving along the propagation of the wave. Compressions are moving in this direction. So there are compressions and rarefactions. Here are compressions and here are rarefactions. Compressions are those points where particles are compressed closer, and rarefactions are those points where particles are relaxed, right? And in transverse waves, the waves travel in the form of crests and troughs. So here are the crests and troughs. So if we go, the vibration is perpendicular to the propagation in transverse waves. So here you can write vibration of particles is perpendicular to propagation of wave. Propagation समझते हो? Propagation means spreading out of wave. And in parallel, in longitudinal wave, vibration is parallel to, you have to write this word, vibration of particle. Vibration of particles. This is very important. Particle is parallel to propagation. ठीक है? ये बात clear है? So examples are all electromagnetic waves, light waves, X-rays, gamma rays, water waves. They all are transverse, and sound wave, horizontal spring wave. They are basically your longitudinal waves. ठीक है? उसके बाद आपके पास आ जाता है some important definitions are there. Crust, all I have discussed with you that all the part of the portion of the wave above the main position. Trough, all the portions below the main position. Compressions and rarefactions के बारे में आपको पता करना है. Compressions are the points where the particles are of the medium are closer to each other, right? Where the particles of the medium are closer to each other. Check this one out. Okay, and the pressure is greater than original pressure. And rarefactions are those points where particles are away from each other. They are far apart from each other. Here we go. For example, if I draw a diagram, let's say here we go. If I vibrate a spring, a coil like this, slinky spring, and I'm going to move it back and forth. Here the particles are closer, so it is compression. Here the particles are apart, so here is a rarefaction. Then a compression, then a rarefaction, and so on. So the particles move in this way. So yes, the mechanical waves and electromagnetic waves have been classified further that they need medium for the propagation, and electromagnetic waves they do not need any medium. They can travel in the vacuum also. Okay, is it clear?
Yes, sir.
Okay. So check this one, this slide. In this slide, the waves have been further classified. Mechanical, they require medium, and non-mechanical, electromagnetic. Mechanical में longitudinals and transfers. In longitudinal waves, sound waves are there. and transfers examples water waves. In electromagnetic waves, they do not require any medium, one of them. And what are those? Light, microwave, infrared, X-rays, ultraviolet, and radio wave. Actually, they are in a sequence: GXULIMR. We have written that in this. So Jexolimer, याद रखना है तुमने. Okay. So these all are. This is basically a summary of what we have studied till now. Then you will talk about the sound wave. Okay. There are some very 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 important sound wave properties. ये जो triple VI लिखा हुआ है ना, it means that these are very important properties. Okay. Sound need a medium for the propagation. It is a mechanical type of wave. The vibration of particles are is along, so that's why it is classified as longitudinal. Speed of sound is 330 meter per second in air, 1500 meter per second in the sound in the liquid, and almost 6000 meter per second in the solid. Okay. Audible frequency range for the human for the sound is 20 to 20 kilohertz. Okay. Is it clear? This is the summary for the sound properties. And loudness of the sound is amplitude of the sound. For example, when I speak louder, I'm not increasing my decreasing my frequency or pitch. I'm increasing my volume, right? So this trace A is louder than trace B. So loudness is how sorry, what is the amplitude of the sound? That is loudness. Our amplitude defines the loudness. And what about the pitch? Pitch is the frequency. So higher pitch, high frequency. It means trace A is having higher pitch and louder. This is trace A. I mean this one. It is high pitch or higher pitch. It has higher pitch and louder. So these are the properties of generally a sound wave. When you profile, अब you देख लो, it is a profile picture of your sound wave. Okay, is it clear to you?
Could you re-explain that a bit, sir?
What pitch and loudness?
Yeah, I don't really exactly understand the
Pitch
difference
क्या
of that
होता है
yet.
देखो. Pitch of the sound is shrillness of the sound. I mean, it is measured with the frequency. If I have high pitch, I will have sound like this. It would be just shrill. मैं वैसे नहीं बना सकता, but it is. But if I have a low pitch sound, it would be grave sound. Like, hello, how are you doing? This is a grave sound, right? I already have grave sound, so I have no need to make it more grave. But to make it shrill or to make it high pitched, I have to make it thin, like मतलब जैसे चीखने की आवाज नहीं होती, just like you're crying or shouting somehow. That is your shrill sound. The sound of the horn, whistling sound. Yes, yes, whistling. Horn बड़े भी होते हैं, grave भी होते हैं. Horn तो ऐसे भी होते हैं पाकिस्तान में. Like the horn of the ship, marine ship. वैसे ही होता है ना?
जी sir.
But whistling of the train is shrill. Like पता नहीं ऐसे ही होती है थोड़ी सी. मैंने वैसे आवाज बना नहीं सका उसकी कभी. So do you understand what is the difference between shrill? I mean, what is the pitch of the sound? So pitch actually is defined by the frequency. So देखो, frequency का मतलब ये हुआ कि when the sound peaks are closer. If the peaks are closer, then it is high pitched. Okay,
Okay.
and if the peaks are higher, the sound is louder.
Okay, now I understand. All right, I understand now.
Yes. So closer the peaks, shrill the sound, high pitched sound. Higher the peaks, taller the peaks, louder the sound. Okay.
Okay.
Okay. Now, this is another important point: how to find the speed of the sound in air. Mostly, this is a question which is asked for 2 to 3 marks. There are different methods for that. First method is, which is performed in your lab. The sorry, this is mentioned in open field, not lab. Lab wala thoda mera khala dusra. Yes, this is in the lab. So it is an open field. In open field, you know what happens? There must be two persons. One person should have a pistol, but there should not be bullets. There should be a cartridge in it. Starting pistol, जिसको हम लोग कहते हैं puff pistol. So when this student A is going to uh, fire the cartridge, or that when it generates the puff, what happens? This student B have an eye contact, and he or she sees this. Yeah, yes, it is being generated. Actually, this is the time t is equals to 0 when your sound has been generated, right? Sound is
Right.
generated at this point, right? At time t equals to 0. Now, because sound takes more time to travel than light, so the light is observed by this observer as it has been produced. It means we consider that there is almost no delay between the observation, sorry, between, sorry, I think you missed this point, between the observation of sound production, sound generation, and reaching to the sorry, reaching its light to the person. So that person will observe it as possible, as quickly as possible, but the sound will take time. ऐसे है ना, slow slow चलती है. So when he will or she will hear the sound, so that is time t is equals to, yani t1 is equals to 0, time t2 is equals to t. So there is a stopwatch with this person. He or she starts the stopwatch. That student starts the stopwatch at time t is equals to 0 when he or she sees the slide, this light, and then stops the stopwatch. This is the ending of the time when the sound is heard, right? This is the time lapse between the generation and reception of the sound. Now is this clear?
Yes, sir.
So, you know what happens here? A person will shot a gun flare at a large distance. We have an observer with a stopwatch. He will start it after seeing the light and stop it after hearing the sound. Repeat it several times to get the average time. Okay, I mean, the students will take several readings. Then the distance should be measured in between these two students. That what is the distance? Let's say they have a distance of 500 meters, suppose, because that in open field. And if the time, average time taken for the sound to be generated and to be received is equals to, let's say, 0.4 or 0.3 seconds, right? So how would be the speed? Speed will be equal to distance divided by time. So it is 500-meter divided by, okay, wait. It is almost 1.5. Sorry, it is almost 1.5. So क्या आंसर आएगा? Do you have a calculator?
Yes, sir, I do. 500 divided by
1.5.
1.5. Okay. That's 333.33.
Yes. What a tukka. I just put this at a trial that, okay, if there is a 500, so it almost it has to take 1.5 seconds. So that is actually because the speed of the sound is almost 330 meters per second. If you remember, we have studied that in first line, 330 meter per second. Check here.
Yeah.
Yes. So is this method clear to you?
Yes,
You can
sir.
even give the reference of these two distances. That distance must be almost 500 meter. So almost the average time will be 1.5 meter seconds. Then the uh, second is second method is actually this one, echo method. This is performed in where we have a small distance, just like lab में क्या होता है, we do not have that much long 500 meter lab तो होती नहीं है. So what we do, we use a closed console method. In that closed console method, what do? We produce the sound by either clap, or we produce the bang of two wooden blocks we usually have in labs. Okay, we just collide those, and there must be two students actually. Student one will uh, start the bang or clap, and student two should be there, who is going to operate the stopwatch, right? So the time must be started when the claps are done, or claps are performed, and time stopwatch is stopped when echo is heard. Echo is heard. Okay, is it clear to you?
Yes, sir.
Okay, so here we do that the distance is measured between the wall from where the sound is being reflected, and we say that it took how much time. It took, sorry, it covered how much distance? Twice of the distance between observer and the wall. So that distance is d, so that is 50 meter almost. Okay, and we say that speed is equals to distance traveled by the sound, not distance between source and obstacle. Distance by sound divided by time taken. Are you getting? So how much distance the sound is taking to be sent and received? Twice of the length between the observer and the wall, isn't it? Divided by time. So that's why for this purpose we take 2d divided by t. Right? Is it clear to you?
Yes, sir.
Okay, so that is the lab method. Now sound cannot travel in vacuum, right? One thing, sound whose amplitude is very low, we are not able to respond it. The sound whose frequency is lower than 20 hertz or higher than 20,000 hertz, we will not be able to respond it. So these are the sounds which cannot be heard. Okay, is it clear to you?
Right. Yes, sir.
Now this is actually the water waves. That was the topic of sound waves. A quick review. That's why I have selected this stuff, that it would make a quick review for you. Then the waves part 3 means water waves. So here we have, these type of questions are asked uh, in your paper, in the worksheet, right? Do you see that? This all,
Yes, sir.
this all. So that means that we are at this last phase of the waves, that is water waves. Actually in water waves we have some properties of the waves, like एक मिनट जरा मुझे देखने दो कि if we have the separate worksheet of the sound and जनरल waves, तो पहले मैं आपको वो सॉल्व करा देता हूँ. तो वाटर वेव्स जब हम लोग करेंगे तो हम इसकी वर्कशीट एक साथ कर लेंगे. यस, this is required, this is required, this is also required. Lenses. Yeah, there was I think you did not receive sound wave worksheet, na?
No, sir.
So that would be mixed then. Sound and general waves. Yes, it would be mixed. These are the sound topics. The diagram shows a graph of the four graphs of drawn for the same scale. The wave has largest amplitude and higher frequency. So very easy. Yeah. These are very easy. The wave fronts and that stuff. Yes. Yes. Okay. So let's talk about uh, those notes which are actually related to the properties of the waves, properties of the water waves. So in properties of the water waves, first property is that reflection takes place, right? What happens? Reflection takes place. Reflection here generally I have discussed about the reflection. Normally आपको reflection किसमें दिखता है? You observe the reflection in your light. Okay, do you get it? Reflection in the
Yes, sir.
light में से ही हम लोग आगे चलते हैं. Actually, this is a mirror of the surface, right? And when the light rays are incident on this surface, we have the normal line. This is called your normal. And the angle of incidence is the angle between incident ray and normal. And angle of reflection is the angle between reflected ray and normal. Don't forget this. This is your angle of incidence. Please ensure this thing that the angle which is between this surface and ray, this is not angle of incidence. Okay, this is not angle of incidence. So this is your angle of incidence, theta I. ठीक है? और फिर आपके पास ये होता है when the wave is reflected back, the angle between reflected wave and normal, that is your theta r. So no, actually रिफ्लेक्शन का रूल ये कहता है कि थीटा आई विल ऑलवेज बी इक्वल टू थीटा आर. एंगल ऑफ इंसिडेंस will always be equal to angle theta r. Okay, is it clear to you?
Yes, sir.
Okay, so this is applicable in all types of waves. Sound में भी reflection का rule यही है. Light has the same rule of reflection. Normally water waves have the same rule of reflection. So that's it. Now reflection is taking place like echo in the sound. ठीक है, echo क्या होता है? Sound reflection को हम लोग echo कहते हैं. If same source, same frequency, same medium and same velocity. This is very important. आपके पास source भी same है. देखो एक ही source है. Frequency of the sound is also same. I mean wave is also same. Medium भी same है. Light is reflecting back in the same medium. Air में है तो air में ही वापस आ रही है. And it has the same velocity. Velocity does not change. This is the point to be noted. Then law of reflection is, this is the law of reflection, that angle of incidence is equal to angle of reflection. We have gone through that. The angle is measured between the ray and normal. देखो ये सारा कुछ मैं बता चुका हूँ. A ray box is used to produce the straight line ray beam. This is specifically in light. But these are the points you have to remember. This is a ray box. ठीक है? Ray box का मतलब simple ये है कि there is a bulb behind this, and we have some cards, and there is a, just we have cut a very thin piece of the card, and that piece makes it a gate for the light. So light वहां से generate हो रही है. In other words, we can use a laser, but most of the time laser is not required. So that is, the light is falling at that. So this is the ray box. अब हम लोग आगे चलते हैं. In this ripple tank, actually reflection means when you are going to stop the wave here, you're not allowing the water to move forward. So water reflects back. So simply speaking, if this red one is the right ray of, I mean, path of incident ray, and this red one is the path of reflected ray, then what to do? सबसे पहला काम ये करना है कि you have to draw a incident ray. You have to draw an incident ray just like this. ray का word use कर रहा हूँ, whatever, if that is water or whatever that is. आपने ये काम करना है. And then you have to draw the reflected one. But okay, it is making a mess here. Let me delete this one. Okay, देखो, are you seeing these two red lines? ये check करो. Do you see that?
Yes, sir.
Now you have to draw a normal at this point where they are going to be intersected or where they are going to hit. This is the point where incident ray and normal ray and reflected ray, they all are actually going to be having the intersection. So this is your incident ray. What is that? That is your incident ray. This is your incident ray. And this is your reflected ray. Reflected ray. अब आपने करना क्या है? When you have drawn these two, you know, you have followed the rule that this is your theta I, that must be equal to your theta r. So you have followed the law of reflection. Now, because in water, you will get the ripple tank and you will get the wavefront. So these all are the wavefronts. So आपने ये करना है कि draw नहीं, एक और पहले काम करना है. Place your scale at the line you have selected for incident ray, right? And spot equal distances at each centimeter. ये ड्रॉ करने के लिए आता है. At each centimeter, 1 0 1 2 3 4 5 6 7 8 सेंटीमीटर. ठीक है. उसके बाद आपने क्या करना है? Then you have to draw some perpendicular lines on these points to the ray. बात समझ आ रही है? I have just shown you how to draw. Rest all is drawn to you. So I hope that you will get it. Right? So these are called your wave fronts, incident wave fronts. Is it clear to you? Yes,
Yes,
Ariba.
sir.
उसके बाद आपने क्या करना है? Then you have to do the same procedure at each 1 centimeter spot. Yani at each 1 centimeter distance, you have to spot the point at reflected ray. और फिर same way में you have to draw the perpendicular lines over there, and those perpendicular lines are, let's say, this is the perpendicular line at this position, this is the perpendicular line at that reflected ray, this is the perpendicular line. So these are your reflected wave fronts. What are these? Reflected wave front. So now that is basically your incident and reflected diagram. ये देखो, that is very simple to draw. In this way you can do it, right? ये थोड़ा सा it is locked here because the lines should be meeting at this point. This incident ray, this is reflected ray, and you have to draw these lines. Blue lines are wavefronts, red lines are light यानी directions of incident rays. पहले आपने incident rays draw करनी है. Then you have to make the angle of incidence, the angle of reflection from the normal. Then you have to draw the incident waves like wave fronts. Is it clear? And then you have to spot the reflected wavefront. So is this clear to you? The same thing happened here. Check this one out. Any confusion?
So,
Step number
sir,
one.
the ray box is sending out the waves.
Actually, ray box is sending the waves. Generally, it is the line which shows the line, the direction of propagation of the light ray, or
Right.
direction of propagation of the wave. Okay, but actually for water, we have to draw these wavefronts. These wavefronts. This is important in water. Okay, so
Okay, sir.
till that we have gone through that all reflection, and then we have refraction. I will discuss that in probably in next. Okay, wait. Do you have some minute? 5 more minutes? Just 5 minutes?
Yes, sir, I do.
Oh, well done. Then fine. Actually, then refraction is the bending of light, wave, sound, anything when it basically changes the medium. right? When it changes the medium. Medium change means one of the light, the light is entering from either air to glass. ये ला, thank you. पानी ले जाओ वहां से. Right? Either the light is entering from air to glass, either it is entering from deeper to shallower, right? Either entering from glass to air and so on. I mean, medium change होना जरूरी है. क्या जरूरी है? Medium change होना जरूरी है. So when you have this mechanism, the fact or phenomena of light, radio wave, any wave, when it is passing obliquely through the interface between one medium and another or through medium of varying density, then speed is directly proportional to angle. I will explain that. Then that is directly proportional to length and then directly proportional to depth. I mean to say that actually speed changes. First of all, what happens? Speed changes. Due to that, angle change. Due to that, wavelength change. And due to that, I mean, depth is one of the factors. So if depth will change, it will cause the speed to be changed and angle and wavelength will change accordingly. Okay? So here is that for light wave, what will you do? If this is a glass slab, is a glass, and light is entering from air to glass, check karo, air to glass, and here is the angle of incidence, and then we have angle of reflection. This is your incident ray till that point. Okay. Now this ray has an angle with the normal. This is the normal. So it is got angle of incidence, theta I. Right? Now this ray will bend. It will no more passing in the same direction. It will bend in this way. ये देखो ये गई. Are you getting it? So now the angle here is theta r, angle of refraction. Refraction. So we can say that actually here the light has been bent, our wave has been bent. So simply speaking, that when a wave enters from one medium to another medium, it bends. So you can say that bending of wave from one medium to to other is called refraction. What do we call it? Refraction. Okay, is it clear? So you have to remember one thing, that ratio of sine of theta I to the sine of theta r is always constant, and that constant is called your n. So I can say that n is equal to sine of theta I to sine of theta r. That is your refractive index. Okay, ji? That is your refractive index. And one more thing you have to keep in mind, that if the light is entering perpendicular to the surface, it will not bend. It will pass as it is. Okay. Then in water wave, what happens when the when the water moves from deeper to shallower portion? What happens? Shallower mean in shallower portion it slows down. Here is the point. Depth decreases, angle decreases. Check this one. Angle decrease, wavelength decrease, speed decrease, frequency remains unchanged. This is very important. You have to keep these 4 points in your mind, that whenever the water wave is entering from deeper to shallower, deeper water to shallower water. So what happens? Definitely depth decreases. Then mm, angle with the normal decreases. Wavelength and speed decreases. Okay. Then the normal is perpendicular to the surface, I mean interface. The ray is perpendicular to the wavefronts. I have told you earlier. Here is that. This is the ray. Arrow wala kya hota hai aapka? Ray hota hai. So ray is perpendicular to Oh, sorry. This is the ray, and this ray is perpendicular to what? That ray is perpendicular to. Oh, why I'm not getting this ray at the same time? At third try, I could not hit it. Wow, निशाना ही खराब हो गया. Okay, so just check this one out. That is your blue one is also your ray. मैं इसको red कर देता हूँ ताकि it should be differentiated. ये देखो, ये आपकी incident ray है. This one is your refracted ray, right? And the normal to the surface is this one. मैं इसको draw कर लूँ. Normal क्या होता है? Normal is the perpendicular line. So you can say that this is the normal. So check whether the angle of incidence decreases or not. I mean, angle with the normal decreases or not. Is it not? And angle of incidence is greater. Here, this angle is greater. Theta I is greater than this R. So you have to keep these points in your mind. Okay? And then finally, diffraction is there. Diffraction is simply speaking, when a wave is entering from a narrow opening, it bends like this. Okay? So if the gaps are, yes, here is very important. Ideal diffraction when the wavelength is equal to the gap size. Okay, when the gap is much smaller than wavelength, it does not pass. But if the gap is much bigger, what will happen? It will also not pass. It will also not diffract. Check this one out. This is the real time diagram. कहीं top से उन्होंने लिए. So these are the waves coming, and these are the waves which are bent there. So if the gaps are closer, these are the gaps. If these gaps are closer or equal to the wavefront wavelength, the waves would bend. Okay, is it clear to you?
Yes, sir.
So that will be just simply to your all waves. Then we have light waves. Light के ऊपर थोड़ा सा हम लोग कल बात कर लेंगे. Isn't fine? Isn't it fine? Prism के ऊपर बात करनी है. कुछ questions मैंने तुम्हें बताने. So that's it. Light के ऊपर कल बात करनी है because it is a long topic. A
Okay.
long way go. Lenses हैं, prism है, and there are some other stuff as well. ठीक है? Yes, these are the electromagnetic waves. So generally we have discussed about light waves, sorry, sound waves and your water waves. So which worksheets can you try now as a homework? Worksheet number one, right? Worksheet number one. You can solve that worksheet now. Okay, ji? Check. These all are the same type of questions we have gone through. And yes, your homework is just worksheet number one. That is fine. Then we will talk about worksheet number 2 and 3 later on. Okay, ji?
Okay,
Yes,
sir.
Sariba? So we will discuss the worksheet as well tomorrow in the class.
Okay, inshallah.
Inshallah. Okay. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.